Hi, I'm Melika. Today we are learning the science behind the center of mass or COM. The center of mass of an object is the point at which that the object can be balanced, or we can suppose all the mass of the object concentrate on this point. It's important to understand where the center of mass is when we are trying to calculate things, that where is this object gonna go when we push it. So, if we push something along the center of mass, it is gonna move in a straight line. But if we push something out of its center of mass, what's gonna happen? It's gonna rotate around the center of mass. It's not gonna in a straight line. Look at this. When we push something along the center of mass, and when we push something out of its center of mass. The center of mass is important when we are thinking about how to balance an object. For example, in this experiment, things get really interesting irregular shaped object because sometimes the center of mass can actually be outside the object. To show you what I mean, let's see this experiment. I need a spoon, a fork, matchbox, and a glass. So the first thing I want to do, I want to make something like this structure and put match in between the middle two prongs at the fork, like this. And just balance irregularly shaped object on the glass. Okay. The whole reason this works is because the center of mass of this fork spoon system is actually outside the object, not in the fork or the spoon. It is where that the match is balancing on the glass or means edge of the glass. Now take another match and light both ends of the match that balancing your fork and the spoon. It still stays up. That's because the ends of the match weren't doing anything in terms of balance. That balancing point remains intact. It is still right on the edge of the glass.